Alright, we're looking at an application of a linear function. In 1999, a home is worth $180,000, and in 2009, it's worth $245,000. We want to write a function w of x, where x is the number of years since 1999, and w of x is measured in thousands of dollars, to estimate when the value of the house, when it was worth $219,000. We also, as an added bonus, want to know what does the slope of w of x represent. So first, we need to take a look at what information we're given. Here, we're given two data sets. If you want to think about it, what they've given us is 2 points. Now, we have to be careful. X here is the number of years since 1999. So in 1999, our x value must be 0 since, well, at the time, that hasn't passed any time since 1999. Now for our y value, for us, w of x, we want the value of the house in thousands of dollars. The house was worth $180,000 in 1999, so our value for w of x here is just 180. Keep in mind it's already measured in thousands of dollars. We have one data point. Now we can get our second data point, because in the year 2009, the same home is worth $245,000. A little bit of work to do. In the year 2009, x has a specific value. 10 years have passed since the year 1999. And for the value of the house measured in thousands of dollars, our value for w of x would be 245, since the house is worth $245,000. Now we're going to make an assumption here. I don't know that this house increases in value at the same amount every year, but for our purposes, we can assume a constant rate of change overall. Overall, the value of the house is increasing. Because we're assuming a constant rate of change, this is where we can define it as our slope. Our slope we can now calculate using our slope formula, y2 minus y1, delta y divided by x2 minus x1, delta x. And I'll be using the two values they've given us. 245 minus the 180, calling them y2 and y1, 10 minus 0 for our x2 and x1. So we have our slope. It's going to be valued at 65 for my delta y, 10 for the delta x, which we can just call 6.5. Now keep in mind, for the numerator, this was measured in thousands of dollars for delta y, and delta x was measured in number of years. So we have our slope m, and conveniently we have 2 points. Since we have 2 points, quick note here, we have a y-intercept. We have a y-intercept because I recognize one of the values where x is 0. So I will not have to use point-slope form. I can go directly into our slope-intercept form of a line. We know the slope, that is m. We know the y-intercept, which means we can use the value for b. So now our function, w of x, what that house is worth, is going to be 6.5x plus that initial value of 180. We want to solve a problem. I want to know, when is the value of the house $219,000? So what we have is a linear equation. 6.5 plus 180. When is this going to be equal to? But for the $219,000 value, remember, we're only going to use the 219. Our W was already measured in thousands of dollars. So continuing, our 6.5x plus 180 equal to 219. We can now solve our linear equation subtracting from both sides. So we have 6.5x equal to 39. And now dividing both sides in order to solve for our variable, we get that x is equal to 6. Now keep in mind, this is not the year 6. This means it happened 6 years after 1999. So 6 years after 1999 means the value of the house was $219,000 in the year 2005. So in 2005 is when the house was worth $219,000. Now we did have a second question. Our slope was 6.5. We want to know, what does that represent in the context of this problem? Because it's positive, we know that the value of the house increased. Increased because it's a positive slope. Now the number we had was 6.5. 6.5, but you know, it was originally measured in thousands of dollars. Our x's were measured in years, so we really should translate this correctly. 6.5 times 1,000, $6,500 per year. So even though we had that number 6.5, in the translation, that would be 6.5 thousands of dollars, or $6,500 per year.